Hello, and welcome to part 3 of Module 5 Network Design and Planning. So, in this session, we are going to look at IP address planning and VLAN design. Basically, what we are going to look at it is from the design consideration point of view. So, when we are designing a network, what care has to be taken when you're selecting the IP addresses or creating an IP address scheme, and with VLAN design, what are the important design considerations that you need to take care of. So first, let us look at the design considerations or the considerations for IP address planning. First thing is hierarchical assignment and route summarization. Now, what does this mean is allocate IP blocks in such a way that allows for route summarization, that is supernetting. Now, why this is essential? This allows the core routers to maintain a single routing table entry for the entire site rather than hundreds of individual subnet routes, which drastically improves the router performance. So in route summarization or supernetting, what happens is that your number of entries in the routing table would be less. So as a result, the lookup time will be less and the router would be performing efficiently. But this also means that when you're choosing the set of IP addresses or when you're allocating the set of IP addresses to the routers and the interfaces of routers, to be more precise, you need to be careful that route summarization should be possible, because if you're having discontiguous block of allocations, then route summarization will not be possible. So that is a care that you have to take when you're allocating the IP addresses. The second thing is sizing for scalability or growth. Now, this is another important thing. Always allocate more IP address to the subnet than you currently need. So, if an access layer switch has 48 ports, then allocate more than 48 IP addresses. Now, why this is necessary is because this helps you to expand or rather keep a scalability. So if there is a more devices to be added in the future, you already have an IP address provision for them. Okay, you don't need to rearrange the whole IP address scheme of the entire network. Okay, otherwise you have to add one device, you may have to restructure the whole IP address scheme. So that is the reason why allocate more IP addresses to the subnet than what you need currently. This provides plenty of room for future expansion or wireless devices in that area. The next is avoid overlapping IP addresses. Now, what does this mean? Never use the same private IP subnet space across different sites or branch offices. So let us say if I am having one branch office in Pune, the other in Mumbai, and let's say the third one is in Gurgaon, and let's say Mumbai and Pune, both these branch offices wants to have a connectivity with the Gurgaon branch, or if Mumbai and Pune, even if they want to have a connectivity for some reason, and if both the sites are using the same set of IP address, say both the sites are having 192.168 192.168.1.0 slash 255.255.255.0, which can be written as slash 24. Okay, so if I'm using this same IP address on both the sites, and if I want to connect this both the sites using a VPN, it will not work. Why? Because the router will not know, because at both the ends you are having same IP address. So it's like, A talking to A. So when A is talking and when A is listening, I'll never come to know, and that is where the problem is. So for such things, use the avoid overlapping of the IP addresses. And to make things simple, you can use IP address management tool, which tracks the IP address allocation. So basically, the IP address management tool is nothing but it keeps the inventory of the IP addresses for all the different locations of your network, which may be located in same geographic area or multiple geographical areas. Standardize the numbering scheme. Develop consistent policy for assignment of static IPs within the subnet. Now this helps a lot because you may have multiple system administrators who are working within an organization. You may be having a multiple network engineers who are working within an organization. Every time you don't want to have a look at the reference copy to see which IP address has been allocated to which machine. So have some kind of a standard policy. Let's say, like for example, for a default gateway it will be dot 1. If you are having switches or routers, then from dot 2 to dot 10, whatever may be before the x dot x dot x, that will be allocated for switches. Maybe for servers and printers some set of IP address is kept. For DHCP pool, for end devices to be connected, some set of IP address. Now this can be developed, this standardization policy can be developed by organizations, and every organization may have a different scheme, but it is always good to have some kind of a standard numbering practice within an organization. Adopting IPv6. Even if you are currently running on IPv4 network, design the architecture to support dual stack, running IPv4 and IPv6 simultaneously, so that you are prepared for future IoT and mobile endpoint scaling. Now, as the IoT devices are increasing, as the mobile devices are increasing, this devices also requires an IP address, and most of these devices would require a large number of IP addresses. So if you have large number of IoT devices, like for example, if there are a lot of sensors in the plant, in the organization, the sensors may be IP enabled, that is they are capturing the data, sending it to the centralized location for analysis and visualization. But in such cases you will require a large set of IP addresses. So think about looking at IPv6 as a solution when you require more number of IP addresses. And since you may be having certain legacy systems or old systems which are running on IPv4, you cannot do away with IPv4. So it is always better to look for a dual stack kind of a system. Now those are the considerations which we need to do for IP addressing. Now let's look at the design considerations for VLAN. So when we are designing VLANs, what are the important things that we need to remember? First is sizing the broadcast domain. It is highly recommended to restrict the standard user data VLAN to /24, which means in one VLAN maximum 254 usable addresses or 254 devices can be connected. Try to restrict to 254. If a particular department has more than 254 addresses, let's say for example 500 network connections, it is more efficient to create two separate VLANs and establish a route between them, rather than deploying one massive VLAN which would suffer from background broadcast noise. So what would happen is, if you have a very large networks, typically you will have lot of broadcast issues that are because of various protocols. Suppose you are having an STP protocol, or that is spanning tree protocol. After a particular amount of time, the spanning tree keeps on sending a polling messages, so that is going to increase the traffic. Or periodically you will be having ARP which is sending some messages. So this whole thing is a broadcast, so there will be a lot of broadcast storms that will be going on within the network. So the good idea would be to design a smaller network and connect them with the help of a router. The second important design consideration for VLAN is categorized by functions. The traffic must be logically segmented based on its operational function and security requirement. A strong architectural design mandates dedicated VLAN for distinct purposes. So you create the VLANs based on the purpose. Okay. So let's say there are VLANs which is carrying only data. So segment by user groups or department. For example, the data VLANs can be separated for students, computer lab, academic staff, institutional administration servers into a separate VLAN which is related to the data only. But VoIP based phones or video conferencing based devices, this requires a certain quality of service. Whereas if you're looking at a data transfer, maybe a file transfer or a web services, or maybe the services which require less of interactivity like telnet or SSH or remote login kind of thing, they can be segmented as into a data VLAN. But anything to do with the voice video, they can be segmented into another VLAN, that is voice VLAN. So IP phones should always be isolated. This allows you to easily apply quality of service policy across the network, prioritizing delay sensitive VoIP traffic over standard data downloads to prevent drop packets and jitters. Then you may have a third category which is related to IoT devices, because there is a specific requirement. It will continuously, maybe after every 5 seconds, 10 seconds, 20 seconds, it will keep on sending some data. So categorize them into a separate VLAN. You may have a separate VLAN for the guest, because you do not want the guest to access the internal network. But yes, they can be provided access to the internet. Like when you join the the hotels, you check in into an hotel, you get a Wi-Fi address. This Wi-Fi address is on a separate VLAN. You cannot access the hotel's internal local area network, right? So that is because it is on a separate VLAN. So this is where you categorize the VLANs on the basis of functions. Inter VLAN routing and access control. VLAN inherently cannot communicate with one another without a layer 3 device or a router or a multi-layer switch. Once you enable inter VLAN routing, the natural isolation is broken. Therefore, the design must incorporate access control list at the routing boundary. See, when you are creating a route between the two VLANs, it means that now anybody and everybody from one VLAN can travel into another VLAN. So the whole purpose of creating a separate VLAN would get defeated. But let's say you do not want everybody to access, but a certain set of people to be accessing that. So let's say, like when it comes to the placements, so you want the TPCs to be accessing the certain data for the placement, but you don't want all the students to be accessing that data, right? So that is where, if I have this as two separate VLANs, I can allow the students, that is, the student is one VLAN and the placement office is another VLAN. I can allow certain students, so I can establish a route between those two VLANs, and through the access control list, I can allow certain students to access the placement data. So only those students will be able to access that data. The rest of the people will be not allowed to access that data. So that's it for now. Thank you.